So as we're looking at this angle relationship, we can see the alternate interior angles. I'm going to go ahead and mark that in green. And that means that I'm just going to kind of write this on the side. Now you have a box to write this. I'm going to kind of write it on the diagram. So this right here is alternate interior angles. And we know alternate interior angles are what? Supplementary or congruent? Or congruent. There you go. So these are going to be the same, 65. So that first one doesn't really require any work. It's just recognizing that those are alternate interior angles. So now we've got 65 degrees, and we've got angle A right next to it. What angle relationship can you notice with that one?
Same side.
They are on the same side, but in this case, they're also right next to each other. Linear pair. All right, and linear pair is a very common angle relationship. You need to be able to see anytime you have adjacent angles on a line, it's a linear pair. All right, so these two are a linear pair. And that gives me a calculation I can use. So again, for your purposes, go ahead and write down that linear pair and alternate interior angles. Write it on the in the box there in that table. I mean, if you write it like this with the arrows pointing to it, that's not the end of the world. So anyways, linear pairs, are they supplementary or congruent? They're supplementary, meaning that these two angles add up to 180. So we don't just say A equals 65, we say A plus 65 equals 180. Now we can solve for A. If you don't set it up this way and you just say A equals 65, of course, that's not the right answer. But now we can get it. A equals what? 115. So down here at the bottom, I can't really fit it into that box. I don't have the full thing, but of course we'd have 115 is our angle measure. Our facts we used was alternate interior angles and linear pairs. Sometimes it requires 2 to get it done. Sometimes even 3.
Sometimes 1. That's not.
What's that?
You sometimes use 1.
Oh yeah, a lot of times it's just 1. In fact, we'll do this with the next one. Solving for angle B. What angle relationship do you think we can use to solve for B? Linear pairs works. We have another one we can use now that we know what A is. What's that? I think I heard it said. Alternate exterior. So we have a couple of ways of solving this. Notice I just extended that red arc down a little bit. But this is another example of linear pairs right here. We could have solved for B right away. We don't need to know A first. But we can solve for B. And yeah, linear pairs can work. We also know A, and so Nick just pointed out that A and B are alternate exterior. They're outside these parallel lines on different sides of the transversal. So we've got a couple of options. So I'll just kind of write that off to the side. That for this one, we can use either alternate exterior angles or linear pairs. On the answer key up here, I put linear pairs, but if yours doesn't match what you see on the answer key, just talk to me, and I can let you know if you did it right and if what you did works. Okay, so you'll hopefully see that a lot of these are very small problems that are just combined together into this diagram. If you get to a point where you get stuck, just come talk to me and we can work through it. But I'll leave the rest of that for you guys. I wanted to go through this entire page, just kind of give you an overview of certain problems. So this is also a good place to start. That first diagram is a good one to start with because most of them are going to be single steps in order to get it done. This is also going to be a good one to start with because it's also going to be generally speaking, single steps to get it done. Like for this, you have the diagram. It gives you two of the angles, angles 1 and 6. You just need to identify what it is. So let's look at that. 1 and 6. What would you call this angle relationship? So this is where it's good to practice those flashcards. You have until Tuesday. Which one?
The 1 and 6. Same side.
The corresponding. These are corresponding. They are same side, so it is fair that you start thinking that way, but notice one of them's interior, one of them's exterior. So they are corresponding because they're both on the left side of that intersection. So we can just fill that one in. Corresponding angles. So go through and see if you can identify all the correct angle relationships for those. Not right at this moment. 13, A through E, will be the same sort of thing. You have to identify under reason what angle relationship that is. But you'll also need to write down what the angle measure is. The calculations here are going to be very simple calculations. You just need to identify, are these supplementary or congruent angles? Use the shape of the angles in the diagram to help guide your thinking. If you forget everything else, just consider, are they both acute? Are they both obtuse? Or is one acute, one obtuse? If they're different, then they're not going to be congruent. They're going to be supplementary instead. Okay, these problems down here it's another example of a type that's actually a pretty straightforward problem. The only change to this is that we have expressions in our diagram rather than one unknown angle and then a bunch of known angles. So if we look at problem C down here at the bottom, we can highlight our angles real quick, draw the arcs. What does this angle relationship look like? Same side interior. And that is correct in this case. Notice they're both inside the parallel lines. That's why it's not corresponding. These are same side interior angles. I'll mark that off to the side. And what do we know about same side interior angles? Are they supplementary or congruent? They are supplementary. And just one look will remind you of that. Because one's acute, one's obtuse. They're definitely not congruent. All right, Tyler, sit up. So supplementary means, I'll just set up the equation. I'm not going to solve it. But 2x plus 13 plus 3x plus 17 equals 180. Those are my two angles. 2x plus 13, 3x plus 17. When I add them together, it has to equal 180. You guys can go through and solve for x. There are decimal answers as you go through some of these problems, A through F. And there's nothing wrong with that. You can just round it off to the nearest tenth when you get that. That's the first decimal place. Okay. Notice for F, it's another one of those situations. I'm not going to go through F. But it's one of these situations where this angle and this one, there's not a direct relationship between them. So you will need to use two angle facts. It would be great if you could say, oh, those are alternate exterior, but that's not the case. So you'll have to do something at first to find another angle measure, and then connect them from there. Okay, any questions on that, just let me know. So the next side has some other problems. Now here's a general takeaway I want you guys to keep in mind when you look at diagrams. If you see a triangle in the diagram, it is a very high probability that you're going to use one of your triangle rules. Triangle sum theorem or exterior angle of a triangle most likely. If you don't see a triangle, you can ignore those rules for that problem. So in problem number 1 right here on the back side of this paper, there's no triangles. So I can completely ignore those. I'm not looking for triangle sum theorem. I'm not looking for exterior angles. Or base angles of an isosceles triangle. You get the idea. If you see parallel lines, you are likely to use one of your parallel line rules. In fact, you're almost guaranteed. Is it going to be your corresponding angles, your alternate interior, same side interior? That depends on the problem. But it's going to be one of those is going to show up. And on the flip side, if you don't see parallel lines, ignore those for that problem because they're not going to be in there. Okay, so this kind of problem, number 1, we can see it does have parallel lines. So I'm automatically thinking alternate interior corresponding same side interior. Maybe one of the exteriors, but we'll see. So the other thing, and I didn't add this to your paper, but when you have a problem like this, you can always add in another parallel line called the auxiliary line. And now, we've already done problems like this in class together. Let's see if we can remember what our process might be. Our unknown is down at the bottom of the diagram, so I need to start up at the top. Can anyone identify an angle relationship in this diagram? I already told you with parallel lines the ones you need to be thinking about.
Alternate exterior.
All right, that's a good guess, but for it to be alternate exterior,
Alternate interior?
no. Alternate interior would look like this. I'll highlight it in red real quick. Those would be alternate interior angles. Alternate exterior.
Same side. Exterior. Wait, no,
All right, that would be alternate exterior right there, what I just drew on the board. And that's kind of hard to see. It's corresponding. So 37 right here corresponds. I'll just call this angle that we don't know right here. No, I can't call it X, and we're already using that. So I'll call this Y. So those two angles right there are corresponding. They're both on the top left of their intersection. Okay, and I'm just going to write it like this. So those are corresponding angles. And what do we know about corresponding angles? Are they A equals B. There you go. They are congruent. So we know angle Y is 37 degrees. Pretty good. All right, now this is the part in the middle that might be a little bit confusing. But we did one like this before. I'm going to see if you guys can remember. I'm going to first of all just create another angle down here, which I'll call angle Z. So I've got Y and Z. If I added them together, what would I get? 75 degrees. So is there any rule, any angle fact, angle relationship we can use in this diagram right here? There it is. Angle addition postulate. So angle addition postulate tells me that, and I'll write this off to the side, angle addition postulate says that my two smaller angles, which are Y plus Z, equals 75 degrees. I already knew the larger one, so I just put the 75 there. Y we already know as well is 37 plus Z equals 75. You guys with me on this one? Okay. So we solve for Z and we get what? 38. All right, so I'll go ahead and show that. 38 degrees. Okay, and now remember, we started at the top of the diagram. We're working our way down. We found another unknown angle. We only have one simple step left to solve for X. What angle relationship do we have? Corresponding angles again. Notice that Z is on the bottom right of this intersection. X is on the bottom right of that intersection. So I've got corresponding angles one more time. And if you can't recognize what corresponding angles look like, then you need to be practicing those flashcards until you can recognize them. All right, they correspond in their position. These are both in the bottom right at their intersection. So that's why they correspond. So there's my answer is, well, I guess we didn't say it yet. What does X equal if these are corresponding? 38. Corresponding angles are congruent. So there it is. So just to recap this problem, we had 3 fairly simple angle relationships. These 2 are congruent because they're corresponding, so they're both 37. These 2 add up to 75, so that one has to be 38. These 2 correspond, which means they're the same, so we got 38. All right, so broken down like that, it's actually pretty straightforward, pretty easy. Yeah?
Can I get some Band-Aids?
No, not right now. When I'm done. Okay, so other problems on that page, one I wanted to look at. This is one that is a little bit tricky at first. If we look at problem number 4 right here, there are 2 unknowns we need to solve for, and we can actually get both of those answers in just 2 steps. 1 step to get the answer for one of them, 1 step to get the answer for the other. But it requires kind of looking at this problem from a different perspective. The first one might be pretty straightforward. Are we solving for A or for B first? Yeah, we're going to solve for A first. We're looking at that problem. Okay, what is going to help us solve for angle A? TST. We've got 3 angles in this triangle. So A. All right, and well, I'll say that in a second. But we've got our triangle sum theorem. You're going to need to write down the equation when you see your test review. So in this case, my equation would be that all 3 of those angles add up to 180. A plus 95 plus 44 all add up to 180 degrees. So if you showed me that, then you would have the correct equation. Then it's just algebra going through and solving that. So can anyone tell me what A equals? 41. Thank you. I'm actually going to write that down real quick on the diagram. It's up to you if you want to do that or not. So the first one, it was 1 step using triangle sum theorem, and we got the value for A. This is the part that's a little bit trickier. We can solve for B, and there are 3 different ways of getting that done. One of them requires 3 steps, one of them requires 2 steps, and one of them can be done in 1 step. So we're going to try and do it the most efficient way we can. I'm going to give you guys just a little bit of time to look at that, see if you can figure out how to do that in 1 step. And what I want you to think about is, what angle relationship do I notice in the diagram that will help me solve for this? That can work. Okay, so Ethan just suggested angles on a line. So let me show you real quick. We've got angles on a line. We've got 64, 44, and this unknown. We could solve for that. And then we could do linear pairs right here. And then we could get, those 2 angles and solve with triangle sum theorem. That's the 3-step way of solving this. We could do 2 steps. So anyways, let me ask this other question. How many triangles are in this diagram?
2.
Okay. There are 3 triangles in this diagram. We've got our smaller one that we already solved with the 44, 95, and A. We've got the one to the left with 2 angles that are unknown and B. But we also have the big triangle here with A, B, and an unknown angle right here. And I'm going to focus on this large triangle. And extend that line out a little bit. Are there any angle relationships with this triangle?
Since you know A, you could just let, and you know that the top one is a 90-degree angle, and you just take A and then...
It's not like that. We don't know that. In fact, it's not 90 degrees. It's a good guess. So let me go ahead and show you. And again, if you do this in multiple steps, it's not a problem. But I've got this angle 66 degrees right here. I've got angle B, and I've got angle A over in the corner. This is an example of exterior angle of a triangle. Okay, so what I can say, and hopefully you can see that, I know that my angle 41 plus my angle B have to add up to give me 66 degrees. Can you guys see that? All right. So we kind of have to ignore that line in the middle with the 44 and 95 degree angles.
Wait, just do this.
Yeah.
How was that? Never mind.
All right. So we've got, the exterior angle is 66, so that is A and B combined. We already know what A is, which means B now has to be 25 degrees. All right, and I want to clarify that if you don't solve it that way, it's okay. There are many ways of getting over to solving for angle B, but that's just kind of the most straightforward. As hoping that was helpful for seeing some things. All right, I just wanted to look at one more problem, which we might be able to get done in just a minute or two. All right. And that's on the bottom right of this side of the page. We've got problem number 5. We've got two angles there, F and G, that we need to solve for. So as you're looking at this, I want you to think, does it matter if I solve one of them first? Can I solve either of them first? So do we need to know angle F before we can solve for G? Do we need to know angle G before we can solve for F? No. The order here doesn't matter how we solve it. That's kind of an important thing to figure out. Like in that last example, we needed to know angle A before we could solve for angle B, but here the order doesn't matter. So let's start with angle G. Can anyone see a simple way of solving for angle G? I'm going to blank out some of the diagram and see if by blanking out some of the diagram, it's a little easier to tell. No, I haven't heard it yet. Corresponding. So those are corresponding angles right there. 70 and G are corresponding. All right, so I'm going to add all that stuff back in, but I'm going to mark these two angles as corresponding. And that means G equals what? 70 degrees. This goes back to what I mentioned before. If there are parallel lines in the diagram, you will use one of your parallel angle rules. In this case, we use corresponding angles. If we have a triangle in the diagram, we are almost certain to use one of our triangle rules. Which one can we use here?
TST.
We can use TST. What we could do is use linear pairs and solve for this unknown angle I'll call X, and then use TST. But we have a faster way of doing it. What's our faster way of getting this done? I just highlighted 3 angles in green up there. I've got a triangle right here. I've got an angle right there. I've got an angle right here, an angle right here. That's the exterior angles of a triangle. I'm trying to get you guys to notice that one to save you some time. On the test, there will be one of them where I expect you to notice exterior angles of a triangle. All right, so now we can see that our exterior angle 100 equals the opposite interior added together. That's F plus 70. So F is now 30 degrees. There it is. So those are all of them I wanted to go through in class together. Reminder, if you need more help, come in and try and get some outside of class. Tomorrow is going to be a work day in class. I'll give you your formal review, and you can look through that. That might not take you the full time, so you can look through other problems on this page, whatever you don't get through today. So look through this stuff, practice with those flashcards. That's how you're going to get yourself prepared for the test next Tuesday. All right.